Hey guys, we are starting on a new topic. So this is chapter 8. We're jumping straight into 8b, unions and intersections. So, oops, this branch of mathematics, you might hear of it referred to as set theory, right? Sets. And so to kind of introduce us to this topic, I've got this diagram that I showed you guys many lessons ago. I think it was quite a few lessons ago when we were talking about irrational numbers. As you can see, I've got that grayed out as my focus. Well, it's kind of a useful diagram to help us understand what a set is in mathematics. So this diagram is just a representation of all of the numbers that exist in this mathematical universe, right? All the numbers from negative infinity to positive infinity, they all sort of exist in this diagram, and they're grouped into sets, right? So we have different types of numbers, and these different types of numbers, we group them into their own unique sets. And these sets, so we have, for example, integers, rational numbers, irrational numbers, imaginary numbers, real numbers, and the set of all numbers, which we would refer to as the set of complex numbers. They all exist in their own unique, set, right? So that's what a set is. It's talking about a region that contains all numbers and objects of a similar nature. So yeah, this diagram, I hope that paints the picture okay. A set in mathematics, it's kind of just like a region in the mathematical plane that contains these particular type of numbers. And you see that these sets, they have relationships with each other. So for example, I can see that my integers exist inside my rational numbers. I can see that my rational numbers and irrational numbers are mutually exclusive. They don't intersect, right? There's no numbers in my rational numbers that exist in my irrational numbers. Whereas all my numbers in my integers set exist within my rational number set. So there's different sets that kind of group, similar sort of numbers in mathematics, and they kind of interact with each other almost. They all exist together in this big sort of planar numbers. So just to kind of carry on from that, I've got some notes for you guys. So maybe just pause the video and copy down what's highlighted real quick. Give you guys a sec to do that. But yeah, let me just talk about it really quickly. So a set, as I've got it written down, is defined as a group of objects, in this case numbers and letters and things of that nature. Not literal objects, but just a group of mathematical objects. Okay, so that's what a set is. It's just a group of mathematical objects. A sample space, that's the set of all possible objects. So from negative infinity to positive infinity, those are all of my possible mathematical objects. If I were to say, well, this is the set of all my possible mathematical objects from negative infinity to positive infinity, I'll put a big circle around them and say that's a set of numbers. Well, that would be called a sample space because it is the set of all possible objects, right? So a set around negative infinity to positive infinity would be a set around all possible objects, and we'd call that a sample space. Another example of a sample space, if I said, what's the sample space of me rolling a die, or the sample space of the outcomes for me rolling a die? Well, the outcomes of me rolling a die are 1, 2, 3, 4, 5, 6. So the set that contains all possible outcomes of me rolling a die would be a set containing the numbers 1, 2, 3, 4, 5, 6. And so we might say that the sample space of rolling a die is squiggly bracket 2, 3, 4, 5, 6. We might say the sample space of rolling a die is, well, defined as we see it here. And yeah, I haven't just picked these squiggly brackets for no reason. Every time we list a sample space or just a list of numbers in maths, it's these squiggly brackets that tell us, oh, it's a list that we're talking about. Alright, so here is a list of the outcomes possible when rolling a die, or in other words, the sample space, every possible outcome achievable when rolling a die. Alright, a few more sort of small details, I guess. Yeah, so why this diagram is kind of helpful. When we talk about sets, we're talking about Venn diagrams in maths. Okay, so sometimes, oh shoot, sorry guys. So a null or empty set, by the way, that's kind of, I like this denotation of it because that's saying there is nothing inside this sample space. So there's nothing inside this set. So it's an empty set or a null set. Okay, so intersections, unions, we're going to talk about that now. Mutually exclusive, just like here we saw rational numbers and irrational numbers, they don't intersect at all. These sets do not intersect. There's no numbers in rational numbers that also exist in irrational numbers. These two sets are mutually exclusive. Okay, so let's just talk about some Venn diagrams for a minute. Some notation we need to know about. So if you're writing down notes, I would say pause here and just copy all of this down into your notes. All right. So some notation. We'll start with this guy. So what's highlighted? That's A intersect B. So when we have our sort of well, it's this sort of symbol. It's either going to be flipped up like this or flipped down like this. When it's flipped up like such, we say this is A intersect B. And what that means, this is what is A and B. So if we look at these two sets of numbers, there's some mathematical objects that exist in A, there's some mathematical objects that exist in B. Well, there's actually also an overlap. So some objects that exist in A also exist in B. And the region that represents that overlap is this intersect. So on a Venn diagram, we can see this is the intersect clearly. But if we were to sort of name it, we would say A intersect B. That is just what is A and B. Okay, A union B. So when we see our little shape thingy is flipped upside down, our union symbol is flipped into a U shape, that means A union B. So A union B, this translates to A or B. So here's two sets of A. Oh, sorry, here's a set of A, here's a set of B. So there's mathematical objects in A, mathematical objects in B, and there's an overlap. So some things in A are also in B. When we say what is A union B, we are considering every mathematical object that is either A or B. Okay, so this was A and B. This is A or B. All right, last thing. So this little comma, we would generally read that as A prime or A primed in maths. Okay, so what A prime is going to represent for us in this topic, the primed is going to say not. So A prime is not A. So A and A prime, that would be A and not A. So when we're talking about A primed or not A, well, here we see we have a set of numbers or a set of mathematical objects A, and we've highlighted everything that is not in that set A. Okay, so that is A primed, not A. And one kind of final note on A and A primed, if we're talking about the probabilities, so let's say I'm randomly looking at these sets and I'm saying, let me pick something out of A, let me pick something out of B, let me pick something out of this region that's neither A or B. What is the probability of picking a number out of either of these regions or either of these sets? Well, the total probability that I either pick something out of A or I don't pick something out of A, that's 100%, right? So there's 100% chance that either A or not A will occur, right? Because it's either I eat an apple or I don't eat an apple. I'm either going to do one of those two options. So it is 100% chance that some combination of of A and not A will occur. So what does that mean? We can rearrange. We can determine then that the probability of not A is going to be 100% subtract the probability of A occurring. So that's the last thing I'd like you to box. I'd like this whole working out section boxed next to A prime, please. Your Venn diagram on A prime. Alright, so if you missed it and you don't want to rewind, I'll just give you that screen again so you can pause it, get it in your notes. And here's just a quick little quiz for you. So again, pause here and really stop and try answer these questions. So what area? So A intersects not B. So A and not B. What is A and not B? What would I have to shade here? Not A or B, right? Not A union B. What is not A or B in this Venn diagram? And what would I have to shade to kind of represent that? Finally, C and D. If C and D are mutually exclusive, what would that look like as a Venn diagram? So take 2 seconds, pause here, answer these questions, please. Hopefully you did. Here are your answers. Give your work a mark, please. So for B here, when I kind of say not A or B, it kind of sounds like I'm saying not A or not B either, but I'm saying not A or B, right? So if it's not A or if it's B, that counts. So see here we have not A, here we have B. So even though this is A, so it doesn't satisfy it, A primed, it is technically in B. It's still in set B. So it would count as part of the intersection between, the union between not A and B. Yep. Finally, if two events were mutually exclusive, there would be no intersection at all. There's no overlap between these sets. Okay, I think that about covers it. Yeah, that'll do it.